Hello, everybody. Welcome to Great Learning. A communication network between the sender and receiver should be secure, but that has become a Herculean task since hackers try to eavesdrop to steal confidential information. This sounds quite dangerous. No one would like to reveal their personal information to the outside world. So, today we are going to discuss a way to encounter this problem. The best solution for this problem is encryption. I am Tejashree and I will take you throughout this course encryption. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video. Any queries or suggestions and I will respond to your comments. So let's have a bird's eye view of the agenda for this entire course. Before learning about encryption, you all should know a few basic concepts of cybersecurity. So we learn what is cybersecurity, the need for cybersecurity, what are cyber attacks and few popular cyber attacks. Next we'll discuss what is cryptography and encryption. Then we'll discuss the differences between cryptography and encryption. It's important to understand how does encryption work. Next we'll discuss the opposite of encryption, that is decryption. And then we'll discuss few major differences between encryption and decryption. Later on we'll discuss the different types of encryption. Then we'll discuss the different encryption algorithms and protocols. Towards the end, we'll discuss what is brute force attack. With no further delay, let's get into this course. Before diving deep into encryption, you all should know few basics of cybersecurity. So we'll discuss what is cybersecurity, the need for cybersecurity, what are cyber attacks, and about few popular cyber attacks. All of you know that cybersecurity is a buzzword, but most of you might be wondering why cybersecurity has gained so much of importance in the society. In this digital world, most of us store our personal data over the internet. This personal data could be misused by hackers for various purposes. This might create a nightmare for most of us. So this is where cybersecurity comes into the picture. Cybersecurity is a practice of protecting systems and networks from digital attacks. With the tremendous advancement in technology, the risk involved also increases rapidly. Cybersecurity literally plays the role of a savior that saves us from falling into the pit. Hope you all have understood what is cybersecurity. Let's understand the need for cybersecurity with the example of LinkedIn phishing scam. I guess most of you know what is LinkedIn. LinkedIn is world's most popular employment service website for job seekers. Recently, LinkedIn was subjected to a cyber attack where 500 million users' profile data was sold online. All of you might be thinking, from where did hackers gain this information? Very simple. Hackers sent fraudulent job offers to users, and by making them click on malicious link, the hackers gained all the sensitive information. This sounds interesting, but it's quite dangerous. We have now stepped into a new phase in this digital world where cyber crimes are increasing rapidly with the advancement in technology. So, cybersecurity is playing a major role in protecting data from data breaches in various organizations. So, what is data breach? Data breach is nothing but stealing information from an organization system without the consent of the owner. Hope you all understood what is the need for cybersecurity. Not so long ago that cyber attacks were solely the problem of techies. However, things have changed now. No one can afford to ignore the importance of cybersecurity. Gadgets, phones, or anything that is connected to a computer or internet are susceptible to cyber attacks from criminals. The possibility of data breaches, losing confidential information, and tarnishing the image of a business heightens with these attacks. Cyber attacks tend to access, change, or even destroy sensitive information to the extent of extorting money from users or casually interrupt a business process. Let's look at the definition of cyber attack. Cyber attack is an intentional activity that exploits computers, networks, and enterprises that rely heavily on technology. Few popular cyber attacks that we encounter these days are phishing attack, SQL injection threat, man in the middle attack, malware,
zero-day attack, cross-site scripting, advanced persistent threats, password attack, drive-by attack, denial of service attack, distributed denial of service attack, eavesdropping attack, and AI-powered attack.
Cryptography. Cryptography is common among multiple corporate organizations. Cryptography protects the privacy of data, and when implemented at the right layer, it ensures that the entire CIA triad is met. But what is the CIA triad? CIA triad is a standard for implementing information security. In CIA, C stands for confidentiality, I stands for integrity, and A stands for availability. Confidentiality ensures that the data is accessed only by authorized party. Integrity ensures that the data is kept intact without any foul play in the middle. Availability ensures that the data is available to the concerned parties whenever required. So, hope you have understood what is CIA triad. Now, let's look at the definition of cryptography. Cryptography is the study of techniques for secure communication between sender and receiver. Cryptography is also known as cryptology. The term cryptography is derived from a Greek word kryptos and graphene. Kryptos means hidden and graphene means to write. Cryptography is nothing but the study of protocols to prevent unwanted parties from accessing your data. So, hope you all have understood what is cryptography. Let's move to the next topic. So, now we are going to discuss about one of the most important topic in this course, that is what is encryption. Encryption is nothing but the process of scrambling data such that only authorized users can access the data using encryption keys. An encryption key is nothing but a string of characters that is used in an algorithm to convert plain text to ciphertext. Plain text is nothing but unencrypted data and ciphertext is encrypted data. Encryption is required to ensure confidentiality and integrity. Most of you would have come across the statement end-to-end encrypted on social media. End-to-end encrypted means that the messages sent between two parties cannot be accessed by anybody else except the sender and receiver. Even the service provider cannot access these messages. To encrypt these messages, various encryption algorithms are used. So we'll see what are these algorithms later on. So now let's look at the definition of encryption. Encryption is the process of converting plain text to ciphertext. So what is this plain text? Unencrypted data is called as plain text. Encrypted data is called as ciphertext. Cipher means an algorithm. The text that we get after applying an encryption algorithm is called as ciphertext. Encryption is the fundamental unit of data security. Encryption allows the data to be in the form of encrypted algorithm and then it is placed on the storage cloud. This ensures the protection of data. Even if the data is stored on a third-party provider, one can access the data safely with the help of encryption and decryption keys. Cryptography implementation can be done at various layers and deploying the complexity varies accordingly. So let's first discuss about full disk encryption or FDE. Most of you would have come across a blue screen asking for password before you enter the company LAN credentials. This is nothing but a BitLocker. It is a FDE capability offered by Microsoft bundled with the OS. This ensures that the entire disk is encrypted to protect the data stored in the hard drive of the laptop in case of laptop getting lost. It is one of the simplest and cost-effective way to encrypt the data. So the next one is file-level encryption. As the name suggests, file-level encryption concentrates at the file level. It helps an individual to secure a single file in an effective way. In an organization, many employees store their files in a shared drive. Many employees might be thinking the data saved by him or her is accessed only by them. But that is not the case. Anyone can access the data who has access, and the admin can even overwrite the data. This issue can be overcome with the help of file level encryption. So next one is database encryption. This is one of the most important type of encryption since it deals with the database which carries all the data. Database is nothing but an organized collection of data. For a better imagination, let's consider the example of a phone backup which is stored in a database which is secured using a different type of encryption. The most widely used one is TDE, that is nothing but Transparent data encryption. There are many positive things about TDE, but it also has few limitations. TDE encrypts the data only in the transit. It encrypts only columns and tables, but it leaves configuration files and log files unencrypted. Since database downtime is highly impactful, the database admins ensure that there are no fancy things in the database as it affects the performance of the system. Application layer encryption. This is one of the most strongest but the most time consuming one. The encryption and decryption takes place at the application layer. This means that the data is encrypted before transmitting or getting stored. Hope you all have understood what is encryption. So let's move on to the next topic. All of you have understood what is cryptography and encryption. So it's time for you all to understand the difference between cryptography and encryption. Cryptography is basically the study of techniques such as encryption and decryption, whereas encryption is the process of converting plain text into ciphertext. Cryptography deals with the study of protocols, whereas encryption deals in establishing a secure connection between two parties. Cryptography deals with the techniques, whereas encryption deals with mathematical operations and algorithms. In short, cryptography is the superset of encryption. So, hope you all have understood what is the difference between cryptography and encryption. Understanding the definition of encryption is not sufficient. You should also understand how does encryption actually work. So, let's discuss the working of encryption. So, just imagine Alice wants to send a message to Bob. Let's say the message is hello. The sender is Alice and the receiver is Bob. Three more parameters are mentioned in this diagram, that is plain text, ciphertext, and secret key. Plain text is nothing but the unencrypted data. Ciphertext is encrypted data. Secret key is nothing but a string of characters that is used in the encryption algorithm. Plain text is usually represented in lowercase and ciphertext is represented in uppercase. The message hello that is sent by Alice is passed through an encryption algorithm. Once the algorithm is applied, it is converted to a ciphertext. The message can be decrypted by the receiver Bob only if he has a decryption key. This decryption key is distributed by the key distribution center. The key is known only to the sender and receiver. The decryption key can be same as the encryption key or it can be different also. So this is how an encryption process actually happens. Encryption is the process of protecting sensitive data from hackers. It prevents eavesdropping attack. Eavesdropping attack is nothing but stealing confidential information while it is being transmitted between the sender and the receiver. So eavesdropping attack prevents a secure connection between the sender and the receiver. So hope you all have understood how does encryption actually work. So far you guys have learned what is encryption. So it's time for you all to understand the reverse process of encryption, that is decryption. Decryption is the process of converting ciphertext into plain text. Ciphertext is the encrypted data. Plain text is the unencrypted data. All of you know that ciphertext is represented using uppercase letters and plain text is represented using lowercase letters. Just imagine the sender is Alice and the receiver is Bob. Alice wants to send Bob a secret message. The secret message is encrypted using a secret key. The actual message, which is nothing but the plain text, is passed through an encryption algorithm which results the ciphertext. The ciphertext can be decoded with the decryption key. The decryption key is distributed through the key distribution center. The decryption key is made available to the receiver even before the message arrives from the sender to the receiver. There are various encryption and decryption algorithms to encrypt or decrypt data between two parties. So, hope you all have understood what is decryption. So, all of you have understood what is encryption and decryption. So, let's see what are the major differences between encryption and decryption. Encryption is the process of converting a normal message into an unreadable form, whereas decryption is the process of converting an unreadable data into a normal data. Encryption is the process of converting a plain text into ciphertext. Plain text is nothing but the normal data. Ciphertext is the encrypted data which is an unreadable form. Decryption is the process of converting ciphertext back to plain text. In the encryption process, the message is encrypted by the sender. In the decryption process, the message is decrypted by the receiver. For example, if Alice wants to send Bob a secret message, Alice will encrypt the message and send it to Bob, whereas Bob will decrypt the message sent by Alice. In the encryption process, a message is encrypted using a secret key or a public key, whereas in decryption process, the message is decrypted using a secret key or a private key. So hope you all are clear with the major differences between encryption and decryption. So the next topic is types of encryption. There are basically two types of encryption, that is symmetric encryption and asymmetric encryption. So let's see what are those one by one. The first type is symmetric encryption. Symmetric encryption is also known as secret key encryption. In symmetric encryption, the message is converted into an unreadable format. Only the authenticated user who has the decryption key will be able to decrypt the message. One of the major disadvantages in symmetric encryption is key management. If an unauthorized user gets hold of the secret key, then the entire secret data has to be compromised. In symmetric encryption, the secret key used for encryption and decryption are the same. The key used by the sender to encrypt the message is same as the key used by the receiver to decrypt the message. Symmetric encryption is fast and efficient when compared to asymmetric encryption. But before discussing about asymmetric encryption, we must discuss the different types of symmetric encryption. There are two types of symmetric encryption, and they are block cipher and stream cipher. Block cipher. Block cipher basically converts blocks of plain text into blocks of ciphertext. The block size depends on the algorithm. The block size should not be too small or too large. It should be multiples of 8 bits. It usually processes 64 bits or more. Stream cipher usually converts 1 byte of data at a time from plain text to ciphertext. It usually processes 8 bits of data at a time. Block cipher is simple but slower when compared to stream cipher. Few popular symmetric encryption algorithms are two-fish, blowfish, DES, triple DES, AES, etc. Asymmetric encryption. Asymmetric encryption is also known as public key encryption. In asymmetric key encryption, there are two keys. One is public key and the other is private key. Public key is known to all, but private key is kept as secret and is known only to the owner. The public key and the private key should be connected to each other. Let's understand asymmetric encryption with the help of an example. Just imagine Alice wants to send Bob a secret message. Alice encrypts the message using the public key, whereas Bob decrypts the message using the private key. In asymmetric encryption, to encrypt the message, the sender should know the public key of the receiver. So the message is encrypted using the receiver's public key. The receiver will be able to decrypt the message using the private key. So the private key should be secured safely. Asymmetric encryption is secure and it ensures data integrity. So hope you all have understood the two types of encryption, that is symmetric encryption and asymmetric encryption. Encryption algorithms and protocols. Encryption algorithm is a mathematical procedure that is used to encrypt the data. Encryption protocols are nothing but security protocols used along with encryption algorithms to secure data efficiently. First, we'll discuss about encryption algorithms and next we'll discuss about encryption protocols. We will be discussing about 5 popular encryption algorithms, and they are triple DES, RSA, AES, blowfish and twofish. So let's see what are these one by one. The first type of encryption algorithm that we'll be discussing is triple DES. Triple DES is also known as TDS. Triple DES full form is Triple Data Encryption Standard. Triple DES is a symmetric key block cipher. The DES cipher is applied 3 times to each data block. The key size of DES cipher is 56 bits. DES cipher was susceptible to brute force attack. Developing a new algorithm would consume more time and money. So the existing algorithm was modified by increasing the key size. That's when triple DES came into the picture. The key size of triple DES is 112 or 168 bits. There are two types of triple DES. Triple DES with 2 keys and triple DES with 3 keys. When 2 keys are used, the key size is 112. When 3 keys are used, the key size is 168 bits. The block size of triple DES is 64 bits. When two keys are used, the security of triple DES is 2 to the power 112. And when three keys are used, the security of triple DES is 2 to the power 168. Triple DES is more secure but slower when compared to DES. So now let's see what is the triple DES algorithm with two keys and with three keys. So let's discuss how encryption is done in triple DES with two keys. So initially we consider a 64-bit plain text. P represents plain text. This 64-bit plain text passes through an encryption algorithm. DES cipher represents the encryption algorithm. Cipher means algorithm. At this stage, we use the key K1. After the plain text is passed through an encryption algorithm, we get a cipher text. This cipher text again passes through a decryption algorithm. DES reverse cipher is the decryption algorithm, which is opposite of encryption algorithm. So at this stage, we use the key K2. So when the cipher text is passed through a decryption algorithm, we again get back the plain text. So this plain text is again passed through an encryption algorithm. So at this stage we use the same key K1 that was used initially. So when the plain text is passed through an encryption algorithm, we get a cipher text. So at the end, we get a 64-bit cipher text. C represents cipher text. So we have used two keys, key K1 and key K2. The key K1 is used twice and the key K2 is used once. So hope you all have understood how to convert a plain text into a cipher text in triple DES with two keys. So let's see how the encryption process takes place in triple DES with three keys. So initially we take a 64-bit plain text. P represents plain text. This 64-bit plain text is passed through an encryption algorithm. DES cipher represents the encryption algorithm. Cipher means algorithm. So at this stage, key K1 is used. So the cipher text is again passed through decryption algorithm. DES reverse cipher represents decryption algorithm. So at this stage, we use key K2. After applying decryption algorithm, we again get back the plain text. So this plain text is again passed through an encryption algorithm. So at this stage we use the key K3. So we have used three different keys, that is key K1, key K2 and key K3. So at the end we get a 64-bit cipher text. C represents cipher text. So hope you all have understood how to convert a plain text into a cipher text in triple DES with three keys. So the next encryption algorithm is RSA. The acronym RSA comes from the surnames of the designers Ron Rivest, Ari Shamir and Leonard Adleman. This is one of the oldest algorithms and it is an asymmetric cryptographic algorithm. This algorithm is used to encrypt and decrypt messages using a public and a private key. RSA includes four steps. The first step is key generation. The second step is key distribution. The third step is encryption and the last step is decryption. So let's discuss each step one by one. So the first step in the RSA algorithm is key generation. Initially, you have to consider two large prime numbers, say P and Q. It's better to consider large prime numbers instead of small. If you consider small prime numbers, the public key and the private key will end up to be the same. N represents the modulus for encryption and decryption. Then you must calculate the value of n, which is nothing but P into Q. The phi of n is nothing but the Euler's torsion function. This is nothing but P minus 1 into Q minus 1. After you calculate the Euler's torsion function, you must find out the value of E and D. The value of E should be greater than 1 but less than the Euler's torsion function. And also the GCD of E and Euler's torsion function should be equal to 1. While calculating the value of D, make sure that D into E mod of Euler's torsion function is equal to 1. So after you calculate the value of E and D, you'll get to know what is the public key and the private key. E represents encryption and D represents decryption. The second step in the RSA algorithm is key distribution. If Alice wants to send Bob a message using RSA algorithm, before Alice could encrypt the message, Alice should know Bob's public key. Only after Alice gets Bob's public key, Alice will be able to encrypt the message. At the same time, Bob will be able to decrypt the message only using the private key. The private key of Bob is never distributed, whereas the public key of Bob is transmitted to Alice before Alice could encrypt the message. The third step in RSA algorithm is encryption. Encryption is the process of converting plain text into ciphertext. C represents ciphertext, M represents plain text message. The value of M should always be less than the value of N. The formula for encryption is C is equal to M to the power E mod N. The fourth step in the RSA algorithm is decryption. Decryption is the process of converting ciphertext into plain text. The formula for decryption is M is equal to C to the power D mod N. Hope you all have understood the four steps in the RSA algorithm. So let's understand the RSA algorithm in a better way using an example. So initially consider two large prime numbers, say P is equal to 61 and Q is equal to 53. As I mentioned earlier, it's better to consider two large prime numbers instead of small prime numbers. If you consider small prime numbers, the public key and private key will end up to be the same, which is not secure. Next, we have to calculate the value of n, which is p into q, that is 61 into 53, which is equal to 3233. Next, we have to calculate the Euler's torsion function, which is p minus 1 into q minus 1, which is equal to 60 into 52, that is 3120. Next, we have to calculate the value of E and D. For that, you must assume a value for E such that E should be greater than 1 but less than the Euler's torsion function. And also, E should be co-prime to P minus 1 and Q minus 1. I had mentioned in the algorithm that GCD of E and torsion function should be equal to 1, which is same as the statement. One such number that satisfies all this condition is 17. So E is equal to 17. Next, we have to assume the value of t such that d into E mod of Euler's torsion function is equal to 1. One such number is 413. Now we got the value of E and D. So the public key is E comma N, that is 17 comma 3233. The private key is D comma N, that is 413 comma 3233. Next step is key distribution. So after that, we have to perform the encryption process. So let's consider the plain text message to be 65. After we substitute the values in the encryption formula, we get the ciphertext, that is 2790. This ciphertext is again decrypted using the decryption formula. So we get back the plain text message, that is 65. So hope you all have understood the RSA algorithm in a better way with this example. The third encryption algorithm is AES. The full form of AES is Advanced Encryption Standard. This is one of the most popular symmetric encryption algorithm. DES cipher was replaced by triple DES, but it was comparatively slower. So AES was designed which is super fast compared to triple DES. AES was established by the US National Standards and Technology in 2001 for encryption of electronic data. AES is based on substitution permutation network. Substitution permutation network is a series of mathematical operations used in symmetric encryption algorithm. The block size in AES is 128 bits and the key sizes are 128, 192 and 256 bits. The number of rounds depends on the key size. 128 bits means 10 rounds. 192 bits means 12 rounds. 256 bits means 14 rounds. AES is also known as Ringdale. It converts blocks of 128-bit plain text into ciphertext using keys of 128, 192 and 256 bits. Blowfish algorithm. Blowfish algorithm is an alternative to DES algorithm. It is a symmetric encryption algorithm. Blowfish algorithm is fast and efficient when compared to DES algorithm. The block size in Blowfish algorithm is 64 bits and the key size varies from 32 bits to 448 bits. There are 18 subkeys and 16 rounds with 4 substitution boxes. Substitution box is responsible for confusion between plain text and ciphertext. One of the major advantage of Blowfish algorithm is that it is unpatented and can be used by anyone. Blowfish algorithm is used in password management, operating systems, backup tools, file and disk encryption. Two-fish algorithm. Two-fish algorithm is a symmetric key block cipher. It is suitable for both hardware and software environments. Two-fish was a finalist to become industry standard for encryption, but it lost to AES due to its slower speed. One distinct feature in Two-fish is that it has pre-computed key-independent S boxes. The key sizes in two-fish algorithm are 128, 192 and 256 bits. The block size is 128 bits and the number of rounds are 16. Hope you all have understood the different encryption algorithms. So now let's see what are the different encryption protocols. We will be discussing about four encryption protocols in this course. The first one is TLS or SSL. TLS full form is Transport Layer Security. SSL full form is Secure Sockets Layer. TLS is an upgraded version of SSL. It is one of the most popular and secure encryption protocols. The HTTPS that you find in the URL indicates that the website is secured using TLS or SSL. HTTP indicates that the website is not secure. TLS includes two layers. The first one is handshake protocol and the second one is record protocol. Handshake protocol is responsible for initiating a secure connection between the client and the server. The client and the server authenticate each other and select an encryption algorithm. They also generate shared key using public key encryption. TLS does not perform the encryption process all alone. It uses encryption algorithms such as RSA, AES, etc. to encrypt the communication. Record protocol. Record protocol is responsible for securely transferring the data packets between the client and the server using the shared keys generated during the handshake protocol. The next encryption protocol is IPsec. IPsec full form is Internet Protocol Security. This is commonly used in VPN. VPN is Virtual Private Network. As the name suggests, VPN is a secure private network for transferring data into a network via internet connection. VPN usually hides the IP address of the server and redirects the server where VPN host handles it. IPsec is used with encryption algorithms such as triple DES, AES, etc. IPsec is fast and easy to implement. It is implemented in two modes, that is, tunnel mode and transport mode. In tunnel mode, both the payload and the header are encrypted and sent in a new packet with another header. In transport mode, only the payload is encrypted and not the header. The third encryption algorithm is SSH. SSH full form is Secure Shell. The working of SSH is similar to VPN. In SSH, an encrypted tunnel is created for transferring files. SSH works at three different levels and they are transport level, authentication level, and connection level. Transport level is responsible for establishing a secure connection between two parties, authenticating the two parties, and encrypting data. In authentication level, the client authenticates its identity using authentication methods specified by the server at the transport level. Connection level is responsible for handling all the connections between the server and the client. So the last type of encryption protocol that we'll be discussing is PGP. The full form of PGP is Pretty Good Privacy. Its actual name is OpenPGP. It is used with encryption algorithms such as triple DES, AES, two-fish, RSA, etc. PGP allows the users to encrypt the data and digitally sign over it to ensure that it is authenticated. It also ensures integrity. It is mainly used to secure confidential email information. Hope you all have understood all the encryption protocols. The last topic that we'll be discussing in this course is brute force attack. Brute force attack is usually done to damage the reputation of an organization or to steal confidential information. Let's now look at the definition of brute force attack. Brute force attack is a trial and error procedure used by hackers to crack passwords and encryption keys to gain unauthorized access. One of the greatest advantages of brute force attack is that it is easy to implement and its disadvantage is that it is slow. Brute force attack can be prevented by increasing the strength of passwords, by using multi-factor authentication, and by limiting failed login attempts. Multi-factor authentication is the process of authenticating the user in multiple steps. Few types of brute force attack are simple brute force attack, dictionary attack, hybrid brute force attack, reverse brute force attack, and credential stuffing. Few popular tools used in brute force attack are NLBrute, Rainbow Crack, Aircrack NG, THC Hydra, Hashcat, etc. Hope you all have understood what is brute force attack. Hooray! So we have come towards the end of this course. It's time for you all to recollect whatever you all studied throughout this course. So initially you all learned few basics of cybersecurity. You learned what is cybersecurity, the need for cybersecurity, what are cyber attacks and about few popular cyber attacks. Then you all got to know what is cryptography. Later on, we dive deep into the world of encryption. We studied what is encryption, the difference between cryptography and encryption. Learning the definition is not sufficient, so you'll also got to know how does encryption actually work. Next, we discussed what is decryption, the major differences between encryption and decryption. Later on, we discussed the different types of encryption. There are two types of encryption: symmetric encryption and asymmetric encryption. Symmetric encryption is further divided into block cipher and stream cipher. Next, we discussed about encryption algorithms and protocols. We discussed about five major encryption algorithms and four encryption protocols. What are the encryption algorithms that we discussed? They are triple DES, RSA, AES, Blowfish, and Twofish. What are the different encryption protocols that we discussed? We discussed about TLS or SSL, IPsec, SSH, and PGP. So, totally, we discussed about four encryption protocols. So, at the end, we also discussed what is brute force attack. Hope you all had a great time learning new and interesting concepts throughout this course. Thank you all. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video. Any queries or suggestions and I will respond to your comments.